Hello everyone, this is Omer Akyunci from Ford Otosan, Turkey. Today I'm going to talk about mild hybrid electrification in heavy-duty trucks. Let's check our agenda that we are going to talk about. Starting with introduction and problem statement about mild hybrid electrification. Then, in the first section, we will examine the effect of single and double configuration of AVS 48-volt electric engine on fuel economy. Then we carry on with configuration changes. The effect of P2 configuration on fuel economy will examine. And finishing with conclusion. Introduction and problem statement. As we all aware that our motivation is CO2 regulations. The 2025 CO2 targets are calculated by multiplying the 2019 reference CO2 values and reducing the result by 15%. And for the 2030 targets, this value reduced by another 15%. But with the Green Deal project, 2030 regulations is expected to be 40%. Vehicle CO2 declaration will be simulated by vector tool. Let me explain for those of you who are not familiar with vector tool. To ensure carbon dioxide reduction targets are met, the European Commission has introduced a computer-assisted simulation tool called Vecto. The Vehicle Energy Consumption Calculation tool is a simulation tool uses certified performance data to measure a fuel consumption and CO2 emissions of individual vehicle configurations. Those who do not comply with regulations I have mentioned before will be penalized with €4,250 for each gram per ton kilometer of CO2 exceeded the limit. European OEMs must develop and implement different CO2 reduction scenarios to fulfill the 2030 CO2 regulations declared by European Commissions. And mild hybrid is one of the scenarios that can fulfill the CO2 reduction scenarios. Mild hybrid has vital part of conventional engine development studies. The knowledge developed in mild hybrid electrical vehicle studies will be utilized in the development of third generation diesel engine, which is planned to be serial production by 2030, and the High Efficient Horizon project. High Efficient Horizon project aims for resource efficient and decarbonized transportation system. In this study, battery ratio, battery size optimization, and configuration studies are performed for mild hybrid electrification. Before starting our studies, let me explain mild hybrid electrification first. In 48-volt mild hybrid vehicles, the electric motor provides extra power by connecting different architectures to the internal combustion engine and working together. The 48-volt mild hybrid consists of FE components. These components are battery, DC-DC converter, main inverter, and if we add more electrical components to the 48-volt system, it allows for further improvements in terms of fuel efficiency and drivability. From an architectural point of view, the mild hybrid electrical vehicle architecture is basically defined by the position of electric motor and the type of connection with the powertrain or drivetrain. Among these architectures, P0 and P2 are the prominent ones. In P0 configuration, the electric motor is connected with the internal combustion engine through a belt. In P2 configuration, electric motor is side attached or integrated between the internal combustion engine and the transmission. Let's start our studies with the effect of single and double configuration of AVS 48-volt electric engine on fuel economy. Main purpose of the study is presenting the fuel economy benefit of AVS 48-volt electric motor with two different configurations. Firstly, belt ratio DOE is performed to see which belt ratio can drive the electric motor at the efficient area for each configuration. Secondly, battery DOE is performed to find proper battery capacity for each configuration. Finally, best battery DOE and belt ratio DOE results are compared for single and double electric motor configuration. The assumptions we made while building our model are as follows. Model doesn't have a cooling system, so model has constant temperature as battery is 25 degree and engine is 40 degree. Battery and electric motor system do not have voltage or current limitations in the first level study. Minimum and maximum SOC values are 0.2 and 0.8. Vehicle mass is 40 ton.